In this video, we're going to talk about factoring trinomials where the leading coefficient is not equal to 1. So it does require a slightly different methodology than when it does equal 1. So let's take a look. First of all, whenever there's a greatest common factor, pull that out. If you can do it, do it. If you don't pull out a greatest common factor, the rest of these steps will not work, okay? Be aware. Now, we want to find the product of A times C. So after you pulled out a greatest common factor, whatever the leading coefficient is and the last term is, you're going to multiply them together. Then you're going to find two numbers that multiply to that and add to the middle number. So again, this is very similar in setup to how we were doing it before where A equaled 1. Okay? Now, once you found those two terms, instead of just automatically plugging them into the parentheses like we've done in the past, we're now going to split the middle term into those two terms, and we're going to factor by grouping. So what does that look like? Well, again, in practice, all of this is much easier. So let's start with 4y squared plus 8y plus 3. There are no greatest common factor. There's no greatest common factor, or really, I guess one of the things I have to say here, just as a disclaimer, it means that the greatest common factor is 1, okay? But pulling out 1 doesn't change it. So we say there's no greatest common factor. So we're going to now do the A times C. Now remember, my A is 4 and my C is 3, okay? So when I multiply those together, I'm going to get 12, okay? Now, I want to find two numbers that multiply to 12 and add to 8. Okay, so again, multiply to my AC value and add to the middle term. Now, the two numbers that make that happen is 6 and 2. 6 times 2 is 12, and 6 plus 2 is 8. So what I'm going to do is I'm going to split up my 8y into two terms using that 6 and that 2. So now 8y, I'm going to rewrite as 6y plus 2y. Okay. Now that I have it split up that way, I have 4 terms and I can factor by grouping. So I'm going to take a look at my first pair. What's the GCF for 4y squared and 6y? Well, they both could have a 2y pulled out. Similarly, if we look at 2y plus 3, you'll notice that they don't seem to share a GCF, and this is what I was talking about a little bit earlier. Because they don't seem to share one, the GCF is 1. Okay, so when I've grouped them, I pull the 2y out of the first two, and I pull a 1 out of the second two. You have to write something when we're factoring by grouping. You cannot just leave it blank, okay? Because then we're going to have 2y plus 3 out of both, and that's going to leave a 2y and a plus 1. So again, if you don't write the plus 1 on the outside, you will get yourself confused. Also, something I see a lot is people just forget to write this plus right here. Don't forget the plus in between the parentheses. Very important. All right, so once we pull the 2y plus 3 out of both terms, we're left with that 2y plus 1. We now have our factored form. As usual, check it by multiplying. Make sure it comes out to the same thing you started with. All right, let's do another one. 8u squared minus 17u minus 21. Are there any greatest common factors? No. All right, so we move right on. So now we're going to do our A times our C. So remember, A is 8 and C is negative 21 in this case. Don't forget to include the sign as part of the problem. All right, so when I multiply 8 and negative 21, I'm going to get negative 168. I now want to find the two numbers that multiply to this and add to this. So let me go ahead and I'm just going to make a little chart here. First of all, notice that because it multiplies to a negative, the signs have to be opposite. And because it adds to a negative, the bigger one is the negative and the smaller one's the positive. So like everything I put on the bigger side of my chart will have to be a negative. Okay, so let's start with 1. 1 times negative 168. 2 times negative 84. Let's see, does 3 work? Yes, I think it does. 3 is going to be 3 times negative 56. There we go. 4 works. It's going to be times negative 42. 5 does not work. 6 works. It's going to be times negative 28. 7 works. That's going to be negative times negative 24. 8 is going to be times negative 21. 9 does not work. 10 does not work. 11 does not work. 12 works. There we go. All right, so 12 goes in negative 14 times. 13 doesn't work. And when I get to 14, I realize I already have 14 on the other side. So, okay. Had to do a lot of mental math there. Which of these pairs adds to negative 17? Well, you can go down each one, but you'll notice at the beginning that the numbers are like really big and negative, and at the bottom they're really small and negative. So I'm going to start kind of in the middle. 6 plus negative 28 is negative 22. 7 plus negative 24. Oh, there we go. I like that. So again, you'll notice here that they have it broken up completely, and it's the 7 and the negative 24 that are the key pair of numbers. So that means I'm going to break up my negative 17u into a plus 7u and a minus 24u. Okay. So when I break that up into its two terms, I can now factor by grouping. So looking at the first two terms, the GCF will be u. Okay. And the second two terms, the GCF is 3, but because that leading coefficient is negative in that pair, I'm going to factor out a negative 3. Okay, and notice when I pull out the negative, it is going to make both terms inside the parentheses positive, because a negative and a negative gets pulled out, we're left with a positive. Now that 8u plus 7 can be pulled out of both terms, and we'll be left with that u minus 3 in the second set of parentheses. So now we can check our answer by multiplying. When you FOIL out, combine like terms, it does come out to be what we started with. So one other thing I want to point out is a situation where you have exponents that are not x squared x and a number, okay? It's important to recognize that you can still factor these in a slightly traditional method. So what we're going to do is called factoring by substitution. In this case, we're going to look at that middle term. It's x squared, okay? And we're going to say, all right, is that squared the first term? So x squared squared is x to the 4th, okay? So that works. So what we're going to do is we're going to say u equals x squared. Now, I know this sounds complicated, but I promise it's not. We're just trying to simplify to make it something we recognize. So if I replace all x squareds with a u, it's going to become u squared minus 4u minus 5. And now this is something a lot more recognizable. This is what we've been working with, okay? Because then I can factor this. The two numbers that multiply to negative 5 and add to negative 4 are negative 4 and positive 1. So I can write it, negative 5 and positive 1. So I can write it as u plus 1, u minus 5, okay? Then all I have to do is substitute my value for u back in. U is x squared, so it's x squared plus 1 times x squared minus 5. Then I can check it, I can multiply it out, combine like terms, and it does match what I started with. So again, if your middle term is a square, then your u will be x squared, okay? Now, you can only do this if the biggest exponent is 2 times your smaller exponent, okay? So if you multiply this small exponent by 2 and you get this one, then it's possible to do this. All right, I hope that was a helpful piece of information for you.